Hey there, welcome back on LabHub. So today we're talking about the rotational motion. And mostly the rest of the information you need to know about is a kind of topic you got on a beginner lesson in a circular motion. So let's get started. At first, we need to talk about spin around one axis because this is basically all about the rotational motion. We got some axis here, and we got some body, and it basically spins around the axis. This is the rotational motion. Or we're talking about more real cases, right? We got a robotic hand, and so this hand moves around this axis, right? So this is about the axis. And we also need to know about rigid bodies. A rigid body is a body while moving doesn't change the place where random point of it located. Let me explain. We got a rock, right? Some kind of random rock, right? And we got a point A here and point B. So if we move this rock, like right here, we move it by 5 meters. The distance between point A1 and point A2 will be the exact 5 meters, just like with the point B, it will be a 5 meters too, right? Sorry, 5 meters and 5 meters here. So this is what is a rigid body. And if we, let me draw another rigid body like this. So if we rotate a rigid body, we got its center, right? Center of weight, basically. We got a point A here, we got a point B here. And when we move this stuff, when we rotate a rigid body, each point of it has its own rotational weight, right? When the body, the whole rigid body, rotates around. Right, let me represent it another way. The white is for point A, the blue is for point B, its rotational way, and the purple is for the whole body. So the whole body rotates around its center, and basically this is the mass center. So for a rigid body, every point of it rotates around one axis, but has independent circle of rotation, and therefore same angular velocity. So angular velocity of point A equal to angular velocity of point B, right? But the different linear velocity, because linear velocity equal to angular times radius, while the radius, it's not always the same. And if you don't know or don't remember all the formulas, and including table 2, you can open the description of the video, and there will be a link on our previous lesson about a circular motion. All the formulas or the necessary formulas are there. And now let's talk about torque. Torque is a new term represented like this. And the torque is basically an angular force. Let me represent it like this. We got a door, right? This is a door. And this is its axis. The door rotates around this axis, right? So torque depends on force you apply and location of place where the force was applied from axis of rotation. What does it mean? If you apply force right here, it won't be as beneficial as if you apply the force here. The work applied on it here will be greater if we want to move the door like on a 2 inches. The work at point A will be greater than the work at point B for the same 2 inches. Because here we need to apply less force than here to move it on the same 2 inches, right? And how can it be represented? Torque equals the radius times force applied times sin of the angle. Again, how can it be represented? What is sin? Sin of the angle. We got a door. And basically, this is your radius, right? And this is the force where you apply it. So you push it there, and force applies on the right, while the radius is this stuff, like the radius from one point to two to another point. And the sin is the sin of the angle where you apply the force and where is the axis. So if you apply the force at this point right here, right here, the sin will be 0 because your angle is 0, right? And then the force applied will be 0 too. While if you apply it on the angle of 90, right here, well, this is radius, this is your force, right? Oh, sorry. So therefore, the torque will be just F times radius. Because sin is already 1. We don't need to multiply it by sin again. It's unnecessary. So this is all you need about torque.